We're going to go ahead and go over Chapter 12, Section 4, Probabilities of Disjoint and Overlapping Events. Please pay attention because now we're using the formulas from last class and we're adding something else on. So when you are considering all outcomes of two events, A and B, that's when we're looking at all the different outcomes that it could have. It says union or intersection of two events is called a compound event. Okay, a union or intersection. So union is looking at, for example, the first diagram. Intersection is looking at the second. So what is a union? All outcomes of either of two events, A and B. It doesn't matter the outcome, it's all the outcomes of my events. Intersection, we should kind of know what that is. Keep in mind these look like a Venn diagram that you guys have used in English. So we should kind of understand what's overlapping and what's intersecting. So intersection, only the outcomes shared. So if you're looking at the second diagram, it's specifically these four outcomes. It's just the ones that are shared. Overlapping events that have one or more outcomes in common, and you're going to kind of see how that's used in the examples. Disjoint or mutually exclusive events. It's the same thing. You could either call it disjoint or mutually exclusive. It's the same thing. Events that have no common outcomes. So when I'm looking at this, there's no overlapping. There's nothing in common. But this one has something overlapping that's in my intersection part. So I'm dealing with an overlap or a disjoint. All right, probability of compound events. So please follow along regarding these formulas. So if you're looking at it, it may look like the ones we did in 12.2, but they are a little different. The first one says, if A and B are any two events, then the probability of A or B is this formula. So when you're looking at this formula that's given, something you should know about this is it has the word or. Okay, so we all see it. It has that word or right here, so I'm dealing with A or B. Keep in mind we are not multiplying anymore. There is addition here. And this means that there is going to be an overlap. A or B, that's what I'm trying to find. But it's both events. Okay, any two events. So that means I also have to consider this section right here is my overlap. This is my overlapping of both events A and B, and you're eventually going to see what that means in the examples once we get there. Looking at the next one, it says, if A and B are disjoint events, then the probability of A or B is this. So again, keep in mind if it's disjointed, you could say disjoint events, or you can just call it mutually exclusive. Keep in mind when you're dealing with probabilities, we're writing everything as a ratio. So if I'm adding two ratios or fractions, whatever you want to think of them as, what's the most important thing when I'm dealing with adding of fractions? What do they have to have? What do two fractions have to have? What is it? They have to have a common denominator. So important thing when you're working with these, they have to have a common denominator. Let me fix that. It looks a little funky. You have to have a common denominator. And when you're working with a common denominator, please do not simplify your fractions until the very end because we're dealing with addition. Simplify it at the end so you can keep that common denominator. If you want to do that for both when you're multiplying and you're adding or subtracting, that's the most important thing. Keep your denominators the same. All right, looking at the first example, it says, a six-sided die is rolled. Find each probability. So what do I know about my six-sided die? I'm going to have 1, 2, 3, 4, 5, or 6 as my outcomes. So, following along, this is the probability that the number rolled is less than 3 or greater than 5. Most important thing about these is reading comprehension. You have to know the difference between and or. So, what do I have? I have 2 events. Something that is rolled less than 3. It's going to say or, and then I have to find greater than 5. So, looking at these, let's go ahead and find these. So, event A, we said A is less than 3. So if I'm looking at event A, what numbers are less than 3? What numbers are less than 3? What are my numbers? Good, I have 1 and 2. So what's my probability? 2 out of 6. Okay, that's what I have. So now let me go ahead and look at the next one. This is going to be 3. What numbers are greater than 5, not 3. So B is greater than 5. What numbers are greater than 5? Just 1. So what's my probability for this? 1 out of 6. Is this considered, would you consider this overlap or disjoint? Is there anything overlapping? No, I have a 1 and a 2 for event A and a 6 for B. So good. For this one, it's going to be disjoint. So I'm going to go ahead and write it over here. Or it could also be mutually exclusive. Any one of those are fine. All right, now looking at it, we're going to go ahead and find some information. Formula that I'm going to use for disjoint. Again, you have to know your formulas. It's going to be the probability of A or B is equal to the probability of A plus the probability of B. And keep in mind, I have to have a common denominator when I'm adding. So what are my 2 probabilities? A was 2 over 6 plus B, which is 1 over 6. And now all I have to do is add them. Adding them, I'm going to get 3 over 6. Now I can go ahead and simplify. Simplifying them, I'm going to end up with, let me get a darker color so you can see that. I'm going to get 1 over 2, which could also be written as 0.5. Oof, now I got to change it to a lighter color. Or 50.0%. Keep in mind, big ideas if it tells you to round to the nearest tenths. For your percent, it has to be 0.0, but on your test or quiz that you just had, I would have taken 50%, would have been fine. So these are the answers that I could have, and this was the formula that I used. All right, looking at the next one, this says the probability of rolling greater than 4 or an even number. So let's go ahead and do one that's greater than 4. So this is the first thing that I'm looking for. It says the word or, and it's then giving me even. So going ahead, A. This one says greater than 4. And what are my numbers that are greater than 4? Good, 5 and 6. And what's that probability? Good, 2 out of 6. And the next one, event B, is what? Even. What are my even numbers on my dice? Good, I have 2, 4, and 6. What's my probability for this one? 3 out of 6. Again, don't simplify it until the very end. So, do these have an overlap? Yes, they do. My 6s right here are overlapping. So for this one, I'm going to go ahead and write this is an overlap. And I have to know the formula for my overlap. That's going to be the probability of A or B equals the probability of event A plus the probability of event B minus the probability of A and B, meaning my overlapped section. So, solving it, what am I writing in? I'm going to write my probability of A, which we said was 2/6, plus my probability of my B, which we said was 3/6. And now the overlap part. What's overlapping? 6. How many numbers are overlapping? Just one, because it's 6 for both. So I'm going to write 1/6. That's how I'm getting that 1/6. That's how I'm getting my overlap. Only one number is overlapped. Yes.
You can also multiply. So this is
I'm sorry?
You can also multiply them.
No. We're not multiplying. We're adding them and then subtracting the overlap. It's or. If it was and, then I would multiply, but because we're dealing with this or that.
No, I meant like to find A and B. You can multiply both those probabilities from 1/6, right?
I don't think that's going to work every time. Because you have to find what is overlapping. So it's just the 6. Just 1/6. So now I just have to solve them. So solving them, I'm going to get 4/6. Now I can go ahead and simplify. Simplifying these, if I were to simplify correctly, I'm going to end up with 2/3, which let me get. And then changing that to a decimal would be 0.6, repeating. Again, if you had a round, you would round it. You would not leave it as repeating. And then it would be 66.7 as your percent. So please make sure you know which one they're asking for and know how to find all of them. So this right here, not that one, this would be my answer. Again, depending on what they're asking for. And this is the formula that we use for overlap. All right. Looking at the next slide, because we're giving you this slide with deck of cards, that means this is fair game for your test. We can give you a card question on your test, so please pay attention to what the cards or how the cards are being used and what we have. So you have 52 cards in a deck, in a standard deck of cards. Keep in mind we are not counting the joker, so do not count the joker included in those set of cards. What do we have? We have a total of 4 suits. What are my suits? I have my clubs, I have my spades, I have my hearts, and I have my diamonds. Those are my suits. I have a total of 4 suits. Face cards are the cards with the faces. You have jacks, queens, and kings. And then you have 13 cards in each suit. So you have your ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, and king. So please make sure you understand this diagram. You can have cards within a category of cards. So once we go to the next slide and we're answering the questions, keep in mind some questions can have an overlap. So it says, a card is randomly selected from a standard deck of 52 cards. Find the probability of the given event. So you're kind of going to have to squeeze some of this information in on here because it is kind of a lot to write, but we can go ahead and do them. So the first probability that they're giving us is selecting a 5 or a face card. So I have 2 events. I have selecting a 5. Then they're telling me or, again, this goes back to reading comprehension, depending on if they're giving me or and. Okay, that's going to tell me which formula I'm using. So selecting a 5 or a face card. So those are my 2 probabilities. Event A is 5, event B is face card. So just thinking about this, is this an overlapping event or is this a disjointed event? This is a disjoint, meaning I'm not going to have any of my 5s within my face cards. They're 2 separate things happening. So I'm going to go ahead and write this as disjoint. And then I'm going to go ahead and write the formula for disjoint. My formula for the disjoint is the probability of A or B equals the probability of A plus the probability of B. That's what I'm going to have. Now I'm going to go ahead and I'm going to write my probabilities. So, probability of event A. What's the probability of selecting a 5 out of my standard deck of cards? 4 out of 52. There are 4 5s because there's a 5 in each suit. So I'm going to have 4 out of 52. And then what's the probability of me selecting a face card, which is my B? How many face cards are there? Good. 12 out of 52. And let me go ahead and plug that into the formula that I have. All I'm doing is adding them. So what am I going to add? I'm going to add 4 out of 52 plus 12 out of 52. If you added correctly, you're going to get 16 out of 52. Can that be simplified? Yes, that can be simplified. So I'm going to go ahead and simplify my answer. My answer simplified is going to be 4 out of 13. Changing it to a decimal, 0.3076. Moving the decimal 2 places to the right, I'm going to get 30.8%. Okay, so again, depending on what they're asking me for, if it's a fraction, a decimal, or percent, this is what I'm going to have. And then because it's a disjoint, this is the formula that I used. Okay, so you have to be able to determine which one you're using. Looking at the next one, it says selecting a face card or a diamond. So I have my events, a face card or diamond. So is this disjoint or overlap? What is it? Overlap. I can have a face card that is a diamond. So this is overlap. And writing my formula for overlap, I'm going to have the probability of A or B, which equals the probability of event A plus the probability of event B minus the probability of what's overlapping, which is my A and my B together. So let's go ahead and write down what we have. What is the probability of event A? How many face cards do I have in a deck? I'm going to have 12 out of 52. How many diamonds do I have? I'm going to have 13 out of 52. Now I have to find the probability of A and B. Out of those cards, how many are overlapping? How many face cards do I have that are diamonds? 3. 3 out of 52. And now all I have to do is plug it in and solve. So I'm going to have 12 over 52 plus 13 out of 52 minus 3 out of 52. Again, they have to have a common denominator, so do not simplify until you get to the very end. So looking at these, if you added and subtracted correctly, you would have had 22 over 52. And that does simplify. That's going to simplify to 11 over 26. Which again, as a decimal, could be 0.423. Moving that decimal 2 places to the right. If they're asking me for a percent, it could be 42.3% as my answer. So again, depending on what they're asking us for, just make sure you know how to change those. And this was the formula we used for overlap. Looking at my next question, it says selecting an ace or a 9. So my two events is an ace, keyword it says or, and then the second event is a 9. So finding our probabilities for event A, how many aces do I have? How many aces do I have in my deck of cards? Anybody? I'm going to have 4 over 52. How many 9s am I going to have? 4 as well. Is this disjointed or overlap? Good, it's disjointed. My aces are separate from my 9s. So going ahead and writing the formula, it's the probability of A or B equals the probability of A plus the probability of event B, and all I'm doing is adding. So again, do not simplify until the very end. I'm going to have 4 over 52 plus 4 over 52, and I'm just going to go ahead and add across. So if you added, you're going to get 8 over 52, which again can be simplified. Please make sure you're simplifying it if you can simplify it. 2 over 13, changing that to a decimal would be 0.1538. I'm including the 8 because I'm going to go ahead and round up. 15.4%. And again, this would be my answer. And what formula did I use? This one right here. And looking at the last one, it says selecting a 10 or a diamond. So a 10 is event A. It says or. B is a diamond. So it says overlap or disjoint. Good. This one's going to have an overlap. So let's go ahead and find that information. The probability of event A. How many 10s are there? Also, I'm going to get 4 out of 52. What about probability B, which are my diamonds? How many diamonds do I have? 13 out of 52. And then because it's overlap, what do they both have in common, or how many? A and B. What is it? It's going to be 1 out of 52. So, writing the formula that I'm using for this one, I'm going to have the probability of A or B equals the probability of A plus the probability of B minus my overlap. So, plugging in what I have, I'm going to have 4 over 52 plus 13 over 52, and then I'm subtracting 1 over 52. If you solved correctly, if you added and subtracted correctly, you're going to get 16 over 52, which can be simplified to 4 over 13, changing that to a decimal, 0.3076. I'm writing the 6 because I'm going to go ahead and round up for my percent. 30.8% would be my percentage if that was my answer. And then because it was an overlap, this was the formula that we used. Questions on these? Again, you have to make sure you understand what's overlapping and what's not overlapping by reading the word problem. Of 100 students surveyed, 92 own either a car or a computer. Also, 65 own cars and 82 own computers. What is the probability that a randomly selected student owns both a car and a computer? So, key things here. They're giving me 92 own either a car or a computer. 65 own cars. 82 own computers, and they want me to find how many students owned both a car and computer. So I'm trying to find the probability of A and B given what they gave me. So what do I have? I have two events. What are my two events? Event A is own car. How many own a car? What's my probability? 65 over 100. Just keep in mind, if it wasn't out of 100 students, it would be out of the total amount. So I think on your homework, there's a question that gives you 90s. You should put it over 90, yes.
Why would it not be 92?
Because that's for 92, it's either car or computer. I'm just looking at one event specifically. So that's saying this or this. That's combining my two events. That's giving me event A or B because it has the word or.
Okay.
So I'm just looking at event A, which is how the students that own the cars. Event B would be the students that own just a computer. So that would be 82 out of 100. And now I'm going to go ahead and write my or. So now this one is the students that own either a car or computer. So now this one's going to be 92 out of 100. Keep in mind, own a car has other factors in there, if that makes sense. So now I'm setting it up as my formula. This has to deal with, I'm trying to find the overlap. Okay, that's what I'm trying to find. I'm specifically trying to find my overlap here. So now I'm going to use the formula for overlap. So I have to know that. So solving it, I'm going to use the probability of A or B equals the probability of event A plus the probability of event B minus the probability of A and B, and that's what I'm trying to find. So now I'm going to go ahead and plug in my information. How many people own a car? It's just going to be 65. Or you know what? We could start from the first one. A or B, that's what they gave us. Computer or a car. So I'm going to go ahead and write for this one 92 over 100 equals. Now I'm going to write my event A. 65 over 100 plus how many own a computer, which was 82 over 100. And then this is minus, I don't know. That's what I'm trying to solve for. My I don't know. My overlap. I'm solving for my overlap. This just goes back to algebra, solving it algebraically. I'm going to first go ahead and combine what I have. 65 plus 82, that's going to give me 147 over 100. Bring everything else down. I don't want minus x, so I'm going to go ahead and move it to the other side by adding x to the other side. I'm going to end up getting x plus 92 over 100 equals 147 over 100. And then all I have to do is solve for x. How do I solve for x now? Good. I'm going to go ahead and subtract 92 over 100 from both sides of my equal sign. If I subtract it correctly, x is going to equal what? 55 over 100. Keep in mind, if they ask me to write it as a fraction, simplifying will be 11 over 20. But this one's pretty easy as a decimal. It would be 55. As a percent, it would be 55% on both computer and a car. So this right here would be my answer. And again, because it was an overlap that we were working with, this is the formula I used. Yeah, you can solve these and change them to decimals, but remember, you're not always going to be given a question where it says out of 100. So just think about that. If it's not given you out of 100, I would leave it as fractions and then solve that way. questions, comments, concerns on this one? Okay.